Hello everyone. In this little correction video, I'm just going to go over 6p one more time because someone very kindly uh, helped me out in understanding what we got to do. Oh, I see how this works. Okay. I'm trying out the regular Notes app just because I wanted to see if it was worth anything. Well, you don't pay for it, but just see if it's worth trying out for the videos, if it looks nice or something. Okay, so we're gonna go over 6b real quickly, and we just want to find the Laplace. So, as always, we represent them in. I like the pencil a lot better. I'm not gonna lie. So we represent g at t, which is t squared. So t squared, and then we're gonna do plus. What's it called? So h at t, so 0 minus t squared, and then this would be times u at t minus 2, t minus a. And so we're left with t squared minus t squared times u at t minus t, and then we're taking the Laplace of f at t, which would be the Laplace of t squared minus t squared times u at t minus t. And after this, we're going to apply the linearity theorem and expand that shit inside. So then we got Laplace of t squared times u at t minus 2. Cool. And so the first one's pretty easy. We're going to use like our t to the n formula equals n factorial over s to the n plus 1. And with this, our n is just 2. So we're going to get 2 over s. N plus 1 would be 3. So that's the first one. The second one is what I had trouble with on the last video. And Leo, this absolute legend, described to me kind of what you're supposed to do. So previously, when we had like something like t, also I like this example a lot better. So let's just say you have 2 minus t, right? Like that's your f at t, and you have it u at t minus 2. So you're literally just like to take the Laplace of this, right? You're just subbing in this as t. So that's literally all you'll get. So you'll get t minus t plus 2. So then you'll take the Laplace of 4 minus t. So that's you're just subbing in the t of whatever it is, and it works out, which is kind of what I found was crazy. So in this case, we have minus t, and so we're going to do the same thing. Of course, sorry, I forgot. You also have to bring out the a to the s. So in this case, it would be, e to the negative 2s times the Laplace of 4 minus t. So you could just compute that. In our case, I see that there's no... Oh, hold on. Let me see if this works. Crazy. Okay, cool. This is my first time using this, but I really like the way it turns out letter-wise. I'm going off topic. So in this case, we're going to go e to the negative 2s times the Laplace of t minus 2 squared. And I'm going to double check this quickly by opening up my child's math to see if this ends up being, what I ended up putting as the final answer. Because I ended up doing it with the original really long theorem, but we don't want to use any extra steps here. So we don't know how to do that, so we're going to kind of expand out that polynomial and then take the Laplace of the whole thing. So in this case, you'll get square the first, double the product of the two, and then square the last. And if we do this, we'll get, 2 over s cubed minus 4 over s squared plus 4 over s. And if I want that all under a common denominator, let me move this down really quickly. Oh, that's such a cool feeling. It's like how it is in OneNote or GoodNote, but I don't use that app. I don't know. I don't like it too much. So in green, oh my god, I actually might start using this from now on. This is pretty sick. So in green, we have 2 over s cubed minus e to the negative 2s times, so we want to put everything over common denominator. So we'll have 2, and I'll make this long, s cubed, so minus 4s, and then plus 4s squared. And when I check that with my actual solution, we have minus 4. Hold on, did I? Yeah, double the product of the two. So in my solution, that my final one, I have minus. Oh, I see what happened. Okay, hold on. So then let me rearrange this. So I have 4s squared minus 4s plus 2 all over s cubed minus e to the negative 2s. Okay, so now it's in the form that I need it to be. So the only difference between the only difference between the two is that, so I have that still as negative. Then probably what I got to do is, I think I messed up in when I expanded it in. So when I brought this in, actually wait, no, hold on, is mine even minus 2? Yeah, it is. Okay, so minus 2. Maybe. Because, yeah, I would say my solution's fine, but it's the minus 4s. Oh, it's because it comes positive. It comes positive. Yeah. It becomes g at u t plus a. Plus a. I'm gonna double check that. So then it'd just be positive here, and positive there. This becomes positive. This becomes positive, which means this becomes positive, and now everything makes sense. Okay, cool. So I should probably also timestamp the last video. My bad about that, guys. But yeah, this is the final answer. Thank you, Leo. You're an absolute legend. And yeah, so just literally the whole purpose. If you're gonna remember anything from this video, whatever you got right here, you just shove it in as t, and you make whatever sign it is positive. So you just add it instead of subtract it. And you'll always have it subtraction here because that's what it is in UT. So like u at t minus a, it's always minus, right? And for example, just quickly, if you had 2t cubed times u at t minus 7, it'd be t plus 7 cubed. And then you take the Laplace of that. Don't worry about the symbol. Okay, guys, we'll see you in the next one.